So we are seeing here how the Hyperledger Fabric sample network is being developed. So we have R1 and R2, two organizations here, which are which have a need to transact with each other. So they are part of a consortium here. R4 is an organization which started the network and is part of the administrator here. An ordering service O4 is available here as part of the network configuration. Each of the organizations have their own certificate authority respectively. Now what comes next is the formation of a channel. So a channel is a primary communication mechanism by which the members of a consortium can communicate with each other. So now we have R1 and R2 here. They are part of a channel. Okay. So a channel C1 has been created for R1 and R2 using the consortium definition X1. The channel is governed by a channel configuration CC1. So the CC1 is the channel's configuration, completely separate to the network configuration. So network configuration is separate and the consortium configuration CC1 is separate. CC1 is managed by R1 and R2 who have equal rights over this channel C1. So R4 has no rights in CC1 whatsoever. So the network administrator R1 do not have any rights in controlling the channel configuration. This channel configuration is strictly between the consortium members, which are R1 and R2. So channel C1 has been connected to the ordering surface O4, but that nothing else is attached to it. So this channel C1, whatever the transactions that pass through this channel, they have to be immutably recorded on the blockchain ledger. So that work is done by the ordering service. So the channel C1 is also using O4 ordering service, and but nothing else is attached to it. Now here in the next we see the coming together of a peer. So a peer node P1 has joined the channel C1. So this channel C1 now is connected with a peer P1. Peer P1 physically hosts a copy of the ledger L1. So this ledger L1, whatever transactions are going through in channel C1, these are being recorded in the ledger L1. And ledger L1 is being hosted by peer P1. So P1 and O4 can communicate with each other using channel C1. So whatever is the ordering service transactions being sent to the network, immutable transaction copy of the ledger is done by O4 and it is physically stored with peer 1. So PNOs are the network components where copies of the blockchain ledgers are hosted. So P1's purpose in the network is purely to host a copy of the ledger L1 for others to access. So whatever the transactions have gone through in channel C1 as per the consortium R1 and R2 with the channel configuration CC1, they are being recorded on the network by ordering service O4 in the ledger C1 L1, and this ledger L1 is hosted with peer P1. Okay, now let's have a look at what is this A1, which is the application. So a smart contract S5 has been installed onto P1. So this peer P1 is now having a smart contract, a chain code S5. So client application A1 in the organization R1 can use smart contract S5 to access the ledger via node P1. Now this application is the front-end application. This can be external to the network. So the network N has the peer P1 which is hosting a ledger copy L1 and a smart contract S5. But the application A1 is external to the network. So A1, peer P1 and ordering service O4 are all linked to channel C1. That is, they can all make use of the communication facilities provided by that channel. So whatever the application A1 transactions are recorded, they are sent to channel C1 as per the consortium R1 and R2's application with the channel configuration CC1. They are recorded on the network by ordering service O4 in ledger L1, and smart contract S5 is the logic behind the transactions. Client application A1 is supported with organization R1, and although it is outside the Fabric blockchain network, it is connected to it via the channel C1. So A1 is the application, client application. It could be the mobile application or web-based application. This is external to the blockchain network, but it is connected to the channel C1.